right, thank you for those who have logged in a little bit early here. Got a fun question for you to answer. Got about 50-50 right now. No one is taking the lasers only route. I was hoping there'd be at least someone that saw in point clouds. It's a great way to judge how the audience feels by doing these polling questions to start with, so I get a sense of how many silly jokes I can work into my presentation, or if I need to be very serious today. We're at 60-40 split right now. I expect the rush of attendees any moment now, as everyone's Outlook reminder are popping up and reminding them to log in. All right, can go ahead and close this now. There are the results real quick. A lot of people that feel it's a fake question. There's never too many cameras. All right, well, that's good because a lot of great camera options out there that we have available to you. All right, we're going to do one more. We give a few more minutes here. So this one deals with how you feel about training and where you are presently. All right, good response feedback here. Thank you guys and girls. All right. Just hit 10 a.m. here on the East Coast of the US. We'll be getting started shortly. Just wanted to give everybody a few moments to sign in. So go ahead and answer the polling question if you have not yet. All right, we got 73% of you have voted. That's great. Thank you. Good audience participation. All right, those of you finishing up that last second email before listening and tuning in to this short but very full of information half-hour presentation here. I promise to keep it right on schedule unless we get a ton of really exciting questions at the end. Then all bets are off. But it should be precisely 25 minutes of discussion here today. All right. Last second to respond to this training question. 3, 2, 1. All right. 76% respondents. That's pretty good. And it looks like we probably could do some more camera training with how our cameras work, both on the acquisition side and the processing side, I'm going to say. So hopefully today I provide you a little bit more information and we can push that number more into the know all set, but we'll see how we can, how we do. All right, so let's get started, shall we? All right, so welcome everybody to my webinar. My name is Joshua France, as you might know already, and I'm the Mobile Laser Segment Manager at RIEGL USA, and we're going to talk about cameras. If I can get mine, there we go. So there's an older picture of me hanging out with the VMZ up in Winnipeg, Canada, with its DSLR camera mounted there. So cameras are an important part of mobile mapping. They provide a lot of additional information and almost an easier access to some of it comparatively to point clouds at times. So we're going to cover the challenges, the camera collection, what's important with it, and we're going to provide you some solutions, most importantly, to these challenges. So why should we add cameras? Well, there's a lot of things that you can see in laser data that cameras do a better job of capturing. So in that middle picture there, you can see the monument behind it has a lot of word and text on it and a lot of intricate details that a good laser point cloud might see. But a photo of that same area is going to be much more meaningful to a feature extraction team. And we can see that we've evolved greatly along the path here to get to our current VMX 2HA system with our use of cameras. So, as you know, we have a triple laser system now out that provides lots of different scanner angles to really give you a full scan pattern coverage. So it's very tempting to say, I think my point cloud scan pattern gives me everything that I need. Well, I'm going to try to change your mind today on that and talk about why it's so critical that we have cameras and why it's so useful that we can do so many different things with them, and that it's not a challenge to decide, but yet a blessing to be able to decide. So, a lot of us feel this way about cameras. Am I right? They're slow. They're hard to control. It's a passive sensor, so we better have good lighting. They create a lot of data files, so we have more data management, man. And they can sometimes be not high enough resolution for where we need them. All right, but let's think about the positive then. They're a very good complement to laser data. As you can see in the picture on the right there, there's a lot of things you can pick up pretty quickly with your eye that if you had to zoom in with a point cloud, you might miss because there's just a lot of different things going on there, a lot of different power lines. But our eyes are better trained for the RGB, obviously, because that's how we see. So they provide a critical aid in feature extraction. In fact, one of the major feature extraction firms would say that it's about 50% faster to use photo overlays to do extraction because it tells the feature extraction team what's coming up. It gives them a better hint at that than just looking at a point cloud. So it often provides data that's just not seen, and you can colorize the scanner data and make all your marketing folks really happy with a colorized point cloud. And it's a great way to prove to an end client that the photos and the laser data are aligned because you have an RGB value for every point. And then we get into some of the new areas of application. Pavement, right? Evaluation, inspection. All of this can be looked at better with a photo. All right. We're going to start off with dispelling a misplaced understanding. The VMX 2HA is a GIS collection system. All right. Write it down, highlight it, circle it. This is a GIS system. So what is a GIS system, right? So it's a GIS stands for graphical information system, right? So it presents graphics in a way that we can get information out of it, quite simply. We all much more used to seeing maps that tell us how many COVID cases are throughout the country or throughout the world, right? That's a GIS system. But this is on the geospatial data side where we're collecting information about signs, pavement analysis, sidewalk accessibility, building condition, sign condition, all of that stuff can all be done with the VMX 2HA just as well as high accuracy data collects for surveying as-builts. One-stop shop, right? All right, so jumping topics back into the camera system world. So the 2HA has a lot of changes to it, right? We redid the design. It doesn't look just like the 450, the 250, and the 1HA. It's got a new camera plate on the bottom, right? What's the big benefit to you, the user? Well, it says 10 gigabyte Ethernet, 10 gig E per camera channel. So it allows for multiple high resolution cameras or multiple slightly lower resolution cameras to collect at very high data frame rates, which this illustrates in this image the ultimate way that this can be accomplished. We have 6 cameras on this system plus a Ladybug 5 Plus. Was it a lot of camera data? Yeah, but did it provide us a lot of unique visual ability and different angles of which to analyze and evaluate the data? Yeah, you better believe it did. And what's even better is that you can move these cameras and adjust them per mission. They're not fixed in place. So when it comes down to the selection of cameras, there's a lot of factors that go into it, right? You can spend days probably agonizing over what needs to be accomplished. Well, one of the main things that you have to worry about is how far away do you want to see something? What's the size of the object? And how fast are you going to travel? The lighting is one of those things that you really don't have much control over, right? You have to make do with what you have. So to work around that and make good adjustments, we have 3 key factors that we can adjust and modify. We can select different lenses, which changes the focal length, obviously. We can exchange the exposure time, which helps reduce the motion blur. And we can adjust the frame rate, which gives us more images in a shorter amount of time, which also helps with the motion blur. We have lots of different ways to tackle this. So we're in control, not only of that, but we're in control of the orientation of the cameras. Where are they looking? We also have this ability, as shown in the image there, to filter out a region of interest to allow the automated adjustment of the gain and the exposure time to work in our favor. So if we have a white roof, we can gray it out and not allow it to be used for the selection of gain adjustment, right? This also controls the image size. So you can block out a 12 megapixel camera and make it save data more like a 5 megapixel camera and reduce that footprint because you're taking more images perhaps. And with a different lens, you can take fewer images because you can see further down the road in front of you to identify where all those no parking signs are. So you don't need to have a picture as often and still be able to see where those sign texts are. Lots of things to think about, but the user's in control of it. All right, so now we have recommendations. How should we adjust RIEGL wire to maximize our camera usage? So I'll put out after this presentation a document that includes these, and you'll also be able to rewatch this in the future. But here are our recommendations. So we're talking about the horizontal cameras so that they're facing forward maybe or straight backwards. Some suggestions or recommendations to deal with different lighting conditions. So bright sun, we mean bright sunny Florida day, no clouds. Poor lighting, we're talking about in intermittent shadowing, right? When we're going to use, as you can see, a slower exposure, a slower exposure time, and we're going to have a higher target for that adjustment and a higher gain ability. And then you can also see here we have bit depth, right? Because all of the RIEGL cameras can be up to 12 bits. Now 12 bits allows us to get more information stored in that darker part of the image, and with the new features in RIE process, which allow for camera histogram stretching, we can access that information and pull it out and put it into a viewable spectrum, even on your less than 12-bit depth monitors. All right. So now the sideways cameras. So these are going to be facing the sideways. So they're going to be a little bit, objects could be really close or really far away. So that's the main difference here, right? If you're on a highway, they're going to be further away from you. And so it's going to behave a little bit more closely like the forward-facing cameras. But with the side-facing cameras, you have building facades sort of right there. So the lighting conditions and how it affects the cameras are going to be different. Hence the different suggestions. All right, I'll give you a second to absorb all that, but I will put out a document with this information in it. And again, in order to access this, this is done on the acquisition system side. So this is in RIEGL, pulling out the information ahead of time, setting it up before you start collecting data. All right, pavement cameras. So these are the backwards facing, downward looking pavement cameras, where you're going to have really fast exposure times, as you can see here, in order to capture the most out of those cracking informations. Now we're staying with the 8-bit depth to help control file size and to guarantee storage of data as well at those high frame rates. All right. So if you got that down, or if you need them again, and I don't send them out to you right away, or one of your friends or colleagues missed this and they need to know this information, make sure you send me an email and I'll make sure you get that information promptly. All right, so as I've alluded to, we have some lens choices to consider now. We have both an 8mm and a 16mm lens. So you might go, okay, I'm not a camera guy. How does that affect anything? Right? Where's that benefit me? Well, if you're looking at really good photographs, it's hard to see that right away, right? But it all deals with the center pixel size, right? So in a 16mm lens, the center of the image size of a pixel gets down to 6mm at 30 meters away, where the 8mm is double the size, as you can see. It also changes the overall field of view. So you're getting a wider field of view with 8mm and a smaller field of view with 16mm. As I can see, I clearly created a typo there. I do apologize, but that's supposed to be 16. I was thinking 12 megapixel camera and it jumped in my head. All right, so here's a little bit more of a salesy part. But we have a camera for every mission with the VMX2HA. Now this is a good breaking point to ask you, do you deliver images with your projects? Because obviously we feel that it's important to give lots of different options for cameras, as having 9 ports is quite a lot of external sensor capability. All right. So the vast majority definitely deliver photographs of all of their data sets. That's great. All right, anyone else? 3, 2, 1, closing it. Share those results. So yeah, most people are delivering images with their projects. All right, so we have lots of different cameras, one for every mission. All right, and our system looks a little interesting when you have all the camera ports on there and all those adjustable arms. Now, if I may provide a short soccer analogy here for a long discussion. I'm a big MLS fan. We have our team here in Orlando. We acquired a new goalkeeper over the summer. And I said, oh, that's interesting. But now after several months of play, it's been a real advantage. And we found out that this guy's nickname happens to be the octopus, or El Pupo, because he's from Peru. And he has been absolutely amazing. And his ability to save the ball has really increased his value add to our team. So now I give you the octopus of your team, the VMX2HA. It can adjust its camera arms in many different directions to solve many of your needs and save the project for you. All right, bit of a stretch there, but I thought that'd be a fun analogy. So we have the Ladybug 5 Plus as one of our external RIEGL specifically made cameras. As you can see, the RIEGL housing cameras have the red tip on them that match the red caps of the VMX1H, sorry, the VUX1HA caps, right? Those are the RIEGL made cameras, as our own housings. The Ladybug 5 Plus is the spherical camera from FLIR. And we have some other external camera solutions as well. You can add Sony Alpha cameras, you can add Nikon DSLRs, the D810, just to name a few. And of course, we can also synchronize some external ones as well, and we'll present some of those images, even perhaps phase one. So there takes a look at the pavement cameras. So you can see the cracking very clearly there. If I embedded the photos correctly, I could click on them and zoom in, and you can see the fine definition of that. So this can be used in third-party software like Topodot, can pull the crack depth information from the photos. Then, of course, here's our panoramic images. This is a great feature to have to be able to send an early deliverable out to a client and let them know what you've collected, how you've collected it, what the job site looks like. Real quick deliverable. Also is a great for colorizing imagery, as you can see, or point cloud, excuse me, as all the colors are balanced across the photo, even though the sun is clearly directly in back, it's not washing that out and fading that color across the image. So then we have our different 12 megapixel cameras here. So this is the 16 millimeter lens forward looking. So you can see we're getting a variety of shots here forward looking. We're able to see this sign is not quite visible zoomed out, but when you zoom in, it's very visible, very clear what it is. And you get very good details, you know, the American flag painting on the side of the building there. And the sort of the texture of the walls comes through very clearly. Then the 8 millimeter side lens, you can see this beautiful mural in on Cliffs Building in Lake Wales, Florida. Looks absolutely wonderful. Very scenic old Florida picture. And then we have some other externals that we can add on here. So here's some examples I was able to get from adding on a phase one external camera. This is with the IXM 100, which is a 100 megapixel camera using a 23 millimeter lens. And here's some examples of what that kind of imagery looks like. So the picture zoomed out looks like a lot of other pictures, but when you zoom in on the different ones, you can see you get very clear lettering from very far away. It's looking very nice. Great sign ability to read all that. A very international sign or area here. So how does it work? How does feature extraction aided by cameras? So we enter the home stretch here. Well, for pavement, the laser beam is only so thin and it really can't get down into all the cracks. We have a wide point beam that works well for multiple point detection and vegetation, but doesn't penetrate down into cracks. It's not expected to or intended to. So the pavement cameras give you that. Line work, curves, and sidewalks. It gives clues to the extractor. Right? It gives them that update that's coming up. And you can see on this sidewalk here, there looks like there's something, but the picture of the same area gives you much more details about it, right? Especially with a building facade, right? If we go back, you can see a lot of details are in here with the false color reflectance. It stands out really great. You can see a lot of different things. This looks like a very eclectic shop, lots of things, but until you add the image, a lot of that's not very clear what it is or how it's on there. Especially these features up here at the top of the building. They almost look like here, they might be some, you know, some additional standout molding, like there's a lip here, but it's a different, this is actually painted on, whereas this is clearly an exterior texture, excuse me. So we're gonna wrap this up now and get to some of your questions. Hopefully some folks have thought of some of this. So it's a great GIS system. It provides high accuracy surveys as well, all in one stop. It has flexible camera options. It allows mission adjustable cameras. So one mission you might want pavement, the next mission you might want power line features. Same camera, different orientation, no problem. And it provides, most importantly, aligned cameras, cameras that are connected to the laser data, so it's one cohesive point cloud in the end, which I haven't mentioned yet, provides colorization information. You can see here the lines for the parking space match up, the curve colorization changes correctly, and you can tell where things are. All those are nice, easy to use features in the VMX2HA. Bringing back a throwback to early on PowerPoint presentations with some spinning graphics just for you guys today. So there we have it. That's the VMX2HA and its many wonderful camera features. Okay, as you know, on this back port, here's a great picture to talk about this, is that there's one port occupied by the Ladybug, another port occupied by the backwards facing cameras, right? So that's how we're able to get the two back there. So thank you very much for attending today. And we have about 5 minutes, so I'm right on schedule, paced really well, for some questions. Maybe I'll get you guys going with this question here. What are your clients asking for? Are we hitting the mark right, or we need to look for some more higher megapixel cameras? All right, so far it seems like we're split here, huh? Pretty good response. Okay. This is important feature development here. We need to know this. All right, so that's pretty good. So it seems like most folks are finding that some combination of, yes, the 12 megapixels is good, and their customers are just happy to see some images. But then we definitely have a good third of the group or more that that's finding a lot of clients needing 50 megapixels plus. So those of you that are finding that as a requirement, if you could write maybe a question into me about what the client's looking for, or how or what kind of cameras you think would be useful, that'd be very helpful. All right, any questions from the audience? All right, well, here's my question for you then. All right, which cameras are you most likely to add to your system in the next 3 to 6 months? I didn't put an other option in there, but I'll count Ladybug 5 Plus as an other camera as well, if you have a different one in mind. We are open to looking at different external sensors. Just need to know what you need them to do, what kind of accuracy you're looking for, what kind of compatibility or integration into our backend software would be helpful. All right. Very good. Well, we're almost there at 10:30 already. It's been a quick half hour. I appreciate all of you that logged in today, sharing a little bit of your busy schedule with us. It's very kind of you. Please send me an email of any questions. If you'd rather send them in that format. And there's my email address and contact information once more. And I will say thanks again, and we'll be in touch the next time around. And make sure, if you haven't already, sign up for Intergeo access using the email intergeo@riegl.com. We'll get you free passes for that. Ooh, there we go. Just when I thought there wasn't going to be any questions. Okay, well, these are interesting questions. They have very complicated answers. So for the question about the Ladybug camera stand, if you could email me and tell me a little bit more what you're looking for, I'd be happy to answer that offline. And the lighting condition settings are often going to be the same depending on the view angle. Because poor lighting and overcast have very similar characteristics in terms of camera, especially considering poor lighting is going to be very dark, but it still has some lighting. So this isn't tunnel lighting, just to be clear. And I'll try to, that's a good point. I'll try to define the different lighting parameters in the document that I'll produce with the recommendations. All right, guys, have a great rest of your day.